Okay, I'm going to break lesson 65 into two parts just to make it a little easier for us, okay? So let's try this type of problem. Okay, first thing is we're going to be dealing with radicals in trig equations, all right? We're not talking about people from the 70s, all right? We're talking about the square root sign, the square root. The key idea here is watch for extra or extraneous roots. Watch for extra roots. How can you get extra roots? Well, let me show you how that happens. All right. Simple, straightforward problem. So the sine of x minus the square root of 1 minus sine squared x equals 0. Well, it doesn't matter if it's a sine or just x all by itself. If you have a square root, how do you get rid of it? You isolate the radical. So I take sine x and I set it equal to the square root of 1 minus sine squared x. Then what do? I square both sides so that I end up with sine squared x equals 1 minus sine squared x. Add sine squared x to each side and I'll get 2 sine squared x equals 1, or 2 sine squared x, oops, not 2 sine squared x, equals 1, or sine squared x equals 1/2 sine squared x minus 1/2 equals 0. Of course, you recognize that it's a perfect square, right? We recognize this as the sine of x minus 1 over square root of 2 times the sine of x plus 1 over square root of 2 equals 0. Now I know right here a lot of you would have taken this and then just right here just taken the square root of both sides, but be careful when you do that. You get the sine of x doesn't equal 1 over square root of 2, it equals plus or minus 1 over square root of 2. So that's why I say always factor, because obviously when we factor we don't end up forgetting that extra. So let's look at what we've got here. So from this, the sine of x equals positive 1 over square root of 2. Well, where's the sign positive? It's positive in this quadrant, 1 over square root of 2, and it's positive in this quadrant, opposite over hypotenuse, 1 over square root of 2. We recognize this one is 45 degrees, and this one's 45 degrees short of 180, or 135 degrees. Where is the sine? So that's the solution for this half. Now what about the other half? What about when I'm over here? What about this one? Alright, then for this one, the sine of x is going to equal negative 1 over square root of 2. Well, where is the sign negative? It's negative in this quadrant. Negative 1, opposite, hypotenuse square root of 2. Negative 1, opposite, hypotenuse square root of 2. Which makes this one 180 plus 45, or 225 degrees, and 45 degrees short of 360, or 315 degrees. So you think you're home free. You're just like, oh, I got this. So my four answers are 45 degrees, 135 degrees, 225 degrees, and 315 degrees, and we think we're done. The problem is we are not, because way up here, when we squared both sides, right here, on this step right here, when we squared both sides, and we went from sine equals square root, and then we squared both sides, we created these extra roots. So let's see what those extra roots are. Alright, the way I check this is I take each of my solutions, and in my calculator I take the sign. I usually start with the largest to the smallest because it's easier to delete than it is to add, insert back in, but it doesn't matter. Ask your calculator what's the sine of 45 minus the square root of 1 minus the sine of 45 squared, and it will tell you 0. So you're okay for that one. So that one tells you 0. So that one works. Alright, so 45 works. Oops. Then you put in 135. the sine of 135 minus the square root of 1 minus the sine of 135 squared. That one also equals 0. But something happens when I put in 225. The sine of 225 minus the square root of 1 minus the sine of 225 squared, it doesn't equal 0. It equals negative 1.414. And same thing with 315. How can that be? What, did I do something wrong in my steps? No, my steps were absolutely correct. But what happened was when I squared this side, when you square both sides, you have the possibility, not always, but you have the possibility of creating extraneous roots. And if you can't spell extraneous like I can't, you just say you create extra roots. You create extra roots. All right, so we have to watch for that. But now the problem is sometimes we have to watch for it even when we're not squaring both sides. Sometimes it has to do with the domain of the functions, that we're multiplying. So in this case, it's already factored for us. Yay! So we've got tangent x minus square root of 3 times sine x plus 1. So the question is, when does a tangent equal square root of 3, otherwise known as square root of 3 over positive 1, or negative square root of 3 over negative 1? So tangent, opposite, over adjacent, square root of 3 over 1, or negative square root of 3 over negative 1. Those are the two quadrants where the tangent's positive. Well, that would be 60 degrees, and 60 degrees more than 180 is 240 degrees. Okay, so that's this half. Well, then this one is quite simply then, when does the sine of x equal negative 1? Right, two things multiplied together to be 0. I kind of skipped that part. Either the first one equals 0, which means tangent x equals square root of 3, or the second one equals 0, which means sine x equals negative 1. Well, the sine is the y value. The y value is negative 1 down here at 270 degrees. All right, but when I put in my calculator, it works out great. The tangent of 60 minus the square root of 3 times the sine of 60 plus 1. My calculator says 0. I'm like, yay! And when I take the same thing with 240, so 60 works, 240 works, but when I put in 270, my calculator says error or domain error or something like that. It's like, wait, what? I didn't square anything. Where did I get extra roots? You got extra roots because the domain of the tangent does not exist. The tangent does not exist at 90 and 270. So at 270, the tangent doesn't exist. Last thing we have to be careful of, my output here, my answers are to be between 0 and 2 pi. So I usually wait till I check my answers. 60 degrees, 60 times pi over 180 makes that one pi over 3, and 240 times pi over 180, 63 is 4 pi over 3. So these are your two answers, pi over 3 and 4 pi over 3. Okay, I'll post a second video for lesson 65 on graphing logarithms in just a moment. All right, thanks.